These are notes from Melham's Math 60, Tuesday, April the 14th, section 8.2 on page 700. Today we're doing the quadratic formula, which says if you have a quadratic equation that looks like ax squared plus bx plus c equals 0, where a is not equal to 0, then we can use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So basically, if you get an equation that looks like this, you just pluck out the a, b, and c, throw it into the formula for your two potentially solutions. Problem 13, x squared minus 3x plus 2 equals 0. That looks like this. So a is 1. There's nothing in front of the x squared, so you pretend there's a 1. B is negative 3. C is 2. Make sure that you watch the signs. Sometimes students will forget the sign. They'll just put 3, but it should be a negative 3. So x is equal to negative b. The opposite of negative 3 is positive 3. Plus or minus the square root of b squared. Negative 3 squared is 9. Minus 4ac. A is 1. C is 2. All over 2 times 1. Underneath the square root, that's 9 minus 8. And that's just 1. So 3 plus or minus the square root of 1 over 2. The square root of 1 is just 1. So 3 plus or minus 1 over 2. And we can work them both out. So 3 minus 1 is 2, and 2 divided by 2 is 1. So one solution is 1. And then 3 plus 1 is 4. 4 divided by 2 is 2. So my two solutions to this equation are 1 and 2. Problem 15, x squared plus 12x equals negative 36. Right now, this does not look like our standard form. The right-hand side is supposed to be 0. So to make it a 0, you just add 36 to both sides. So x squared plus 12x plus 36 equals 0. Now this equation does look like our standard form. So our a, b, and c are, again, we have 1, b is 12, c is 36. Plug everything in. X is equal to negative b, so negative 12 plus or minus the square root of b squared. 12 squared is 144. Minus 4 times a times c, 4 times 1 times 36, all over 2 times a, which is 1. So we have negative 12 plus or minus the square root of 144 minus 4 times 1 times 36 also happens to be 144, divided by 2 times 1, which is 2. Well, 144 minus 144 is 0, and the square root of 0 is 0, so we have negative 12 plus or minus 0 divided by 2. But in this particular case, you only have one real solution. Negative 12 minus 0 and negative 12 plus 0 are the same thing. It's still negative 12, and negative 12 divided by 2 is negative 6. So here's an instance where you only have one solution. But in general, there's going to be two solutions. For the vast majority of the problems, that will be the case. Problem 25, 3y squared plus 1 equals negative 6y. Once again, we want the right-hand side to be 0 to make it look in standard form. So I'll add 6y to both sides. And it's also important that you put the elements in the right order. We're going to go 3y squared plus 6y plus 1 equals 0. So it's the squared term, and then the x, or in this case y, and then the constant equals 0. So now this is in standard form. So I pluck out my a, b, and c as 3, 6, and 1, and throw it into the quadratic formula. So y is equal to negative b, negative 6, plus or minus the square root of 36, minus 4ac, 4 times 3 times 1, all over 2a, 2 times 3. And just clean it up. So negative 6 plus or minus the square root of, this becomes 12, so 36 minus 12, divided by 2 times 3, which is 6. And then underneath the radical, 36 minus 12 is 24, so negative 6 plus or minus radical 24 over 6. And 24 I can write as 4 times 6, 4 being a perfect square. So the next step after that, the square root of 4 will come outside and change to a 2. So negative 6 plus or minus 2 radical 6 all over 6. I notice that these numbers are all even, which leads me to factor out a 2 from the numerator. And after I factor out a 2, I'll partially cancel the 6 in the denominator. So 2 times negative 3 plus or minus radical 6 all over 6. 2 was factored out of the top here. And then I'll cancel the 2 with the 6, leaving me with a 3 in the bottom. So negative 3 plus or minus radical 6 all over 3. So those are my two solutions. Remember, this represents two actual solutions. Negative 3 minus radical 6 over 3, and negative 3 plus radical 6 over 3. You could get a decimal approximation for them. In fact, some of the problems in the text that ask you to get a decimal approximation, we're going to forego that. We won't worry about that. You can punch it in your calculator if you wish, but this is not a calculator class. It's an algebra class, so just want you to be able to get to here, then that's good. Okay, problem number 31. 3x squared minus 2x plus 1 equals 0. That's already in standard form. So I just get my a, b, and c as 3, negative 2, and 1. So x is equal to, by formula, negative b, the opposite of b is negative of negative 2. That's a positive 2. Plus or minus the square root of b squared. Negative 2 squared is 4. Minus 4 times a, which is 3, times c, which is 1, over 2 times a, which is 3. 2 times 3 is 6. This comes out to be 4 minus 12. So we're going to be taking the square root of a negative number. So 2 plus or minus the square root of negative 8 over 6. So my solution is going to be complex. It's going to involve an I. All right, so coming back up here, the negative comes outside and becomes an I. So 2 plus or minus I radical 8 over 6. And then 8 I can rewrite as 4 times 2. And that way the square root of 4 will come outside and become a 2 the next step. So 2 plus or minus 2I radical 2 all over 6. And once again, I noticed that this, and this are all even, so I should factor out a 2. So 2 parentheses 1 plus or minus I radical 2 over 6. This 2 can partially cancel the 6. So final answer is 1 plus or minus I radical 2 all over 3. All right, then some variations on the theme for 41. They start you off with a weird fraction, so I'll multiply both sides by 15 to clear out the fractions. So 15x squared minus 14x equals 8. I like that a lot better than having all the fractions. And then in order to use the quadratic formula, remember the right-hand side has to be 0, so I'll just subtract 8 on both sides. 15x squared minus 14x minus 8 equals 0. And now this is in my standard form. So I pluck out the a, b, and c, being 15, negative 14, and negative 8, and throw it into the quadratic formula. So x is equal to negative b. The opposite of b is positive 14, plus or minus the square root of b squared. Negative 14 squared is 196. You can just use your calculator for that. Minus 4 times a, which is 15, times c, which is negative 8, over 2a, 2 times 15. And in this particular case, there's a double negative. There's a negative 4 times a positive 15 times a negative 8. So it's actually going to be an addition. It's 196 plus this product, that times that times that, comes out to be 480. Divided by 2 times 15, which is 30. And 196 plus 480 comes out to be 676. The square root of 676 is exactly 26. So I have 14 plus or minus 26 all over 30. So when you're getting something like this, nice solutions, you should work them both out. 14 minus 26 is negative 12. So negative 12 over 30, which reduces to negative 2/5. Or 14 plus 26 is 40, so I have 40 over 30, that reduces to 4/3. Always reduce your fractions. So my two solutions are negative 2/5 and a positive 4/3. Problem 49, a couple things about that. The right-hand side for 49 is 18. I'm supposed to have a 0, so I'll subtract 18. So negative x squared plus 10x minus 18 equals 0. Okay, normally when you have this situation, we don't like to have our constant our coefficient in front of x squared to be negative. I want it to be positive. So the way to do that is to multiply both sides by negative 1. And if you multiply by negative 1, 0 stays 0, and that just changes all of these signs. So that becomes x squared minus 10x plus 18 equals 0. We usually like that. We want a to be positive, especially since you have to plug in a twice in the quadratic formula. You would prefer it to be positive, not negative. And you can always do that by applying this trick. If a were negative, like here, then you would just multiply by negative 1 on both sides. So I like this better. So my a, b, and c are 1, negative 10, and 18. So x is equal to negative b. Again, we have a negative 10, so that's 10. Plus or minus the square root of b squared. Negative 10 squared is 100. Minus 4ac, so 4 times 1 times 18, all over 2a, 2 times 1, that's 2. 4 times 1 times 18 is 72. And 100 minus 72 is 28. So 10 plus or minus the square root of 28 all over 2. 28 you can write as 4 times 7. And take out the radical 4. The next step, it becomes a 2. 10 plus or minus 2 radical 7 over 2. In this particular case, you're allowed to divide the 2 directly into the 10 and into the 2 radical 2, as long as you divide into both of them. So 5 plus or minus radical 7. Finally, 59, you're given decimals. So just like when we have fractions, you want to get rid of fractions. So whenever you have decimals, it'd be nice to get rid of the decimals. So 0.6x squared plus 0.03 minus 0.4x equals 0. I'm going to multiply both sides by 100 in red. So you might recall if you multiply a decimal by 100, that moves a decimal over 2 spaces, and that'll make all of these nice numbers. They're all integers. So multiply this by 100, 60x squared. Multiply this one by 100, negative 40x. I'm also putting it in order, x squared, then x, then number, to make it look like standard form. And 100 times 0.03 is 3. So now I have it in standard form. 60x squared minus 40x plus 3 equals 0. So x is equal to negative b. Again, I have negative 40, so it's positive 40, plus or minus the square root of b squared. Negative 40 squared is 1600 minus 4 times a, which is 60, times c, which is 3, all over 2a, 2 times 60, and I just clean all that up. So punch this in your calculator. 1600 minus 4 times 60 times 3 gives me 880. The denominator is 2 times 60, which is 120. 880 happens to be 16 times 55. You think of perfect squares again. So if you're wondering what do I take out, think of your perfect squares, which are 1. Well, you're never going to take out a 1. But 4, 9, 16, 25, 36, those kinds of numbers. You're looking for the biggest number that goes into 880 out of that set, and that comes out to be 16. Square root of 16 becomes a 4, so 40 plus or minus 4, radical 55 over 120. And I can factor out a 4 in the numerator, so 4 parentheses 10 plus or minus radical 55 all over 120. And that 4 can partially cancel the 120, so I'll be left with 10 plus or minus radical 55 all over 30. So these are notes from Melham's Math 60, Quadratic Formula, for Tuesday, April the 14th, section 8.2, page 700.